The study of hot melt adhesives involves understanding adhesive materials as a whole. An adhesive is the material which holds solid objects together by means of surface attachment. Hot melt adhesives are one type of synthetic adhesive which are of a thermoplastic nature. Thermoplastic means the adhesives are solid at room temperature, soften when heated, and return to their solid form upon cooling. The bond is made when the molten adhesive cools and becomes solid on the substrate. Hot melt adhesives are polymer-based formulations. The synthetic polymer provides the backbone of the adhesive and gives the hot melt strength and general characteristic properties. Significant backbone polymers for hot melt adhesives include ethylene vinyl acetate, polyethylene, amorphous polypropylene, polyurethane, butyl, styrene, polyamides, polyesters, and polyester amides. Hot melt adhesives may consist of a number of ingredients compounded along with the backbone polymer to give them specific bonding properties. These ingredients can include wax, antioxidants, fillers, plasticizers, stabilizers, or dyes. For instance, in a typical packaging grade adhesive, ethylene vinyl acetate, EVA, is the backbone polymer. Resin provides hot tack or the ability to stick to substrates at elevated temperatures. Wax is added to provide viscosity control. Antioxidants are included to protect the compound from thermal degradation when in a molten state. There are many advantages to using hot melt adhesives in an application. The first is the ability of the hot melt to set rapidly. The rapid transition from the liquid to the solid state allows for higher line speeds, which results in increased production. Floor space requirements can be reduced due to a shorter compression time than with cold adhesives, which rely on the evaporation of their water or solvent carrier to form a bond. Hot melts are 100% solid, which means they contain no water or solvent carrier. Hot melt solid form allows for ease of handling and storage, gives it an indefinite shelf life, and helps eliminate waste. The gap-filling ability of hot melts is a definite advantage in the filling of small recesses and bonding of uneven surfaces or substrates. In some applications, an inert gas can be mixed with the hot melt adhesives to form a foam-like material that takes on some new properties. Increased open time, reduced set time, and increased gap-filling features make foamed materials usable where standard hot melts will not perform well. Since many hot melt adhesives are created to be food-grade safe, their fumes are not considered harmful in the workplace or when vented out into the atmosphere. Also, hot melts contain no solvents. Therefore, pollution and fire hazards are also reduced. Most hot melt adhesives are not sensitive to moisture, which means they are not affected by humidity variations. But there are some hot melt adhesives that are specially formulated to actually cure with moisture present. Moisture cure adhesives form bonds that may be more resistant to the effects of water, chemicals, and additional heat, thereby increasing the reliability of the bond. These adhesives require the workplace be well ventilated. While there are decided advantages to using hot melt adhesives, there are limitations which can be disadvantages for some applications. Hot melt equipment, while simple to operate, requires that the operators have training in maintenance and safety procedures. Hot melt adhesives have limited penetration properties, which in some applications can limit bond strength. Hot melts are temperature sensitive, and they may reactivate if the final product is subjected to temperatures above the softening point of the adhesive. In addition, some substrates may be sensitive to the hot melt application temperature at the time the bond is made. Hot melts may react with certain solvents or plasticizers already in the substrate or applied to the substrate after assembly. With time, hot melts may have a tendency to creep or gradually shift position under load stress. The advantages and limitations of using specific hot melt adhesives must be weighed for each application. Numerous adhesive companies manufacture hot melts. Each company makes various hot melt formulations for a wide range of applications. In addition to various formulations, these companies produce hot melt in many physical forms, including chunks, blocks, cylinders, pellets, chiclets, ropes, pillows, slats, and even 5-gallon pails and 55-gallon drums. The hot melt adhesive formulations are used for an endless variety of applications that generally are related to the assembly or the packaging of products. Some applications common in the marketplace are carton and case sealing, pallet stabilization, bag seaming, can labeling and closure sealing, assembly of furniture, books, automobiles, appliances, insulated glass frames, and non-woven products such as baby diapers. Because of the variety of substrates encountered and the assorted product uses, assembly applications often demand more complex adhesive formulations than those required for packaging applications. There are certain terms used in discussing adhesives in general and hot melts in particular. As previously noted, the substrate is the surface to which the adhesive is applied. Both substrates and adhesives will retain their separate identities, although the adhesive may penetrate into the substrate. Adhesion is the ability of an adhesive to stick to a substrate. Viscosity relates to how easily a material flows. Measured in poise and centipoise, it is the degree to which a material resists flow under applied force. For instance, cold molasses would have a relatively high viscosity as compared to that of cream. The softening point, or ring and ball, is a temperature determined by test procedures for each specific hot melt. It indicates the temperature at which there is a change in the hot melt's ability to flow and is used as a tool to compare the properties of hot melt adhesives regarding heat sensitivity. The application temperature range is from the lowest to the highest temperature at which adequate bonds can be formed while not creating a significant change in the adhesive's physical and chemical properties. The application temperature is the best temperature at which to apply a specific hot melt to a substrate. While the manufacturer of each hot melt will recommend an application temperature, this temperature can be varied within the application range in order to adjust to particular line operating conditions. Once established for a given environment, the application temperature should remain the same. The open time is the amount of time the hot melt stays in the proper molten state to form a useful bond with the substrate. Open time differs from one hot melt formulation to another and can be affected by physical and environmental variations. Two more terms used with reference to hot melt adhesives are degradation and stability. All hot melt adhesives are derived from carbon compounds, which makes them organic and therefore subject to deterioration or degradation. Degradation is indicated by changes in the hot melt material when held at an elevated temperature over a period of time. The ability of hot melt to resist degradation is called stability. Stability characteristics of hot melts, along with other physical properties, are defined on each adhesive company's specification sheet. The stability characteristics are expressed in time and temperature exposure. Viscosity changes due to degradation are expressed as a percentage of change on the specification sheet. Understanding what hot melt adhesive is and how it can be used involves understanding how it is applied to a substrate. Modern industrial hot melt equipment requires three basic operating functions. The first is adding heat to the adhesive to transform it from a solid to a liquid. The second is moving the liquid adhesive to the point of application. And third is controlling the amount and form or shape of the adhesive as it is deposited. Numerous types of adhesive application equipment are available in the marketplace today to meet the wide variety of application needs. One of the simplest is the wheel-type applicator, which uses a wheel rotated in a pot containing the hot melt material. The wheel may print dots or an engraved pattern onto substrates. All the substrates must be uniform in size because of the stationary wheel location. The screw-type melter uses hot melt in a pellet form, which is fed into a motor-driven screw where it is kept cool before it is melted and pushed to an extrusion head. Gear pump-type melters move hot melt material using a gear pump through a heated hose to the application head. Melters of this type provide continuous delivery of large volumes of adhesive and move high viscosity adhesives. Piston pump type melters utilize a reciprocating air piston to push melted material through a heated hose to the gun. The hot melt material is extruded on demand while under constant pressure. This type of applicator will develop medium to high hydraulic pressure with low air pressure input and can use low to medium viscosity adhesives. Drum-type melters are designed to dispense thermoplastic materials for applications requiring a high volume and rapid delivery of material to either a substrate or a heated reservoir. Either a piston or gear pump can be used to pump the material directly from the drum or pail or from an inverted drum in some equipment configurations. With the number of various melter and application heads available, it is possible to meet a broad range of customer needs. The unique properties of hot melt adhesives make them popular in today's industrial market. They offer a combination of advantages to the user, not only in their versatility in bonding a wide range of substrates, but in the savings available in materials, freight and labor costs, floor space, and production time. Ease of application, versatility, economy, and compatibility with environmental requirements all add up to a growing use of hot melt adhesives.